Hi. Alright, as we said, Maths with Kumar takes you this gradient, this slope, alright, from easy to more difficult and more challenging. But I want you to take things with a pinch of salt and not panic. Just smile, move on, gain your strength, and look at the sum. All it requires is what you've studied. That's all. The same knowledge that you require, we're just going to expand it. You have a regular pentagon, PQRST, inscribed in a circle as shown in the diagram. They ask you to show that angle POT is 70 degrees, and they want QSP. QSP is here. They want to find that angle, and OTQ. OTQ, what's that angle? And given that the radius is 3.5, and they ask you to find the area of the minor sector PQO. PQO is this sector they want to find out because you got a major sector, and they want to find the area of the shaded region. So you can see that they are all connected. Now, let's look at it and say, this is a pentagon. And what is each interior angle of a pentagon? Alright, the exterior angle of pentagon. What is it? Exterior pentagon. We're talking about pentagon. That's a 5-sided figure. So what can you say? 5E is equal to 360. So what's your E going to be? You divide by 5, you get 72 degrees. And you know that E plus I is 180 degrees. They're adjacent angles on a straight line. If your E is 72 degrees, what is the interior angle going to be? 108 degrees. Now, once your interior angle here is all 108 degrees, you look at it and say, hey, you, 108. So each one of them, 108 degrees. Now, you want to show if it's 108 degrees, I just want to show you draw here, draw here, draw here, draw here, draw here. Now, you look at the sides very carefully, just look at it. All these sides are equal in length, right? They are all equal in length. Now, if you look at it, there are 6 angles coming here. 1, 2, 3, 4, 5. 5-sided. It's a pentagon, not a hexagon. Okay? 5-sided. There are 5 interior angles. All right? So if they're all meeting here, they're all of equal size. All right? If I call this 5, if I call this as an A, 5 A's, all right, is equal to 360 degrees, because you can see that each of these triangles are congruent, because this side is equal and the 2 angles will divide into 2 equal parts. 54, 54. This is also 54. 54, 54. You can see that is ASA. All right, each triangle is congruent. Maybe you want to write down each triangle, triangles, 5 triangles, all right, and each triangle are congruent. Each triangle congruent to each other. Congruent means they are equal, identical. You can put a property ASA because we can see that this angle is 54 degrees divided by 2 parts. Okay, so that's one way. Or you can say it's 108. You don't have to put ASA, so can. Look at this part. These 2 sides are equal. You can find this angle, and from there you can look. All right, you can look in many ways. You can do. We can do even SSS. Let me take that out here. I want to show you, because they are radius. They're all radius. So I don't have to write even this part, because it's an understood part. You can write it down clearly when you have space. They are all equal. You can see when they come to the center of the circle, these are all radius. Radius, 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 radius. Right? And this length, if you look at it, there are 5 angles coming here. The radius are equal, the 2. So this is the side SAS. Maybe I put double stroke because they may not be the same. All right? SSS, that's the best. Now, having got that, and you know that this angle is 108. Now, we divide it into 2 here. 54, 54. So what will this angle be? 180 minus 108, that would give us 72 degrees. Now they want POT. Oh, where's POT? O is here. POT. What will it be? Angle POT will be, this is 54, 180 minus 54 will give us a 72 degrees. Angle sum of triangle. Alright, so but I put that 5A just for your information if you call them all A's here. Alright, 360 degrees, 360 divided by 5 is also a 72 degree. So both ways, either or, you can take this approach. So we've got that. Now the next thing they want to look is they want to find out, hey, what is angle QSP? QSP. So I'm going to erase these things, the inside. Alright, you can draw it in pencil in your diagram, okay? So we're going to look at it and say, hey, what is it they want? QSP. Alright. Okay, QSP is going to be Q to S, QSP. QSP, look at that, my dear. Now this is an isosceles triangle, right? All this is equal. So this is angle will be, can you tell me what is it? Alright, we have a five-sided figure, it's 108 degrees, 180 minus 108 divided by 2. So this angle here, A1 equals to A2, okay, A1 equals to A2, it's 180 minus 108 divided by 2. It's an isosceles triangle. Just put the reason. And you got a 72 divided by 2 is a 36 degrees. So if each of these angle here is 36, alright, this is also 36 degrees. You want to find out QSP. You want to find out what is this angle. But I'd like to ask you, are these two triangles congruent? Don't you find them congruent? Because this side equals to this side. Yeah, they're equal. This is 108 degrees. Yeah, this angle is 108 degrees. So you can also see that this angle is also 36 degrees. Do you see that? And the whole angle of this interior angle is 108 degrees. So what will this angle be? Alright? Therefore, you please do write down what I'm saying and explain it. You can see that angle QPS, let me write down, angle PST is also 36 degrees because triangle PTS is congruent to triangle QRS. Alright? You can see very clearly. And so if this is 36, this is 36, then therefore angle QSP is this whole interior angle is 108 minus 36 and minus 36. Well, that's about a 72 degrees. 108 minus a 72. Look at it, you get 6, you get a 36 degrees. That's your angle. Wow, they're all equally divided. Okay, so that's your answer. Next part, they want to find out what is OTQ. O is the center here. O, center. OTQ, what is that angle gonna be? Alright, maybe if you can see, let's see how you see it. OTQ. Okay, we want to look at that angle. OTQ. This angle here. Alright, you can see very clearly that this is a radius. Okay, triangle OQT is an isosceles triangle. And we can also see, my dear, if I join here, I join here. Alright, if I look at it, it's an adjoin here, all of you. You look at it, this is, we found out each of them is 72, 72, 72. So this is made of two triangles. right? So we can see that angle QOT, all right, angle QOT is 72 times 2 is 144 degrees. You could see that because this is 72, 72, 72. This 2 is 72 plus 72, 144 degrees. Now, hence, this triangle QOT, all right, is an isosceles triangle as QO and OT are radius. So therefore, all right, angle OTQ is 180 minus 144 divided by 2. We call it the base angle of isosceles triangle. The isosceles triangle is maybe base angle of triangle OQT. So that will give you 180 minus 144 is a 36. 36 divided by 2 is 18 degrees. Alright? Okay, I hope that's clear to you. Now, next thing, they want to find the area of sector PQO. PQO, this sector. Now, this angle here, alright, I will not be able to draw a very nice diagram. We got PQO, I just want to show you. This is PQ, and you got an O here, and this is part of a hexagon, five-sided pentagon, alright? And we know that this is equal, and the radius is 3.5, and the angle here is 72 degrees, right? It's part of a pentagon. You see the parts are all 1, 2, 3, 4, 5. Okay, so this 72 degrees. Now they want to find the area of this sector. What is the area of sector? Area of a sector. Sector minus sector PQO is equal to half r squared theta. The formula half r squared theta. If you're not familiar with that, you know that 360 degrees, alright, is a full circle, and this is 72 degrees. Or you can use this formula, 72 degrees out of 360 degrees times pi r squared. Alright, you can work that out because it's a fraction of a circle. Alright, you can see that, and you can cancel this, is 1/5 of the circle. If you were to use this formula, then you would have to change your 72 degrees to radian. Alright, how do you change the radian? You said 180 degrees is pi. So what is 72 degrees? Pi over 180 times 72. So just want to show you how to do that. That's going to be your radian. Now using that part of it, let's put this part here, half r squared theta. What will that be? I just want to show you both ways of doing it. Half r squared theta. You get your r is 3.5, which is 7/2, right? Your r. And your theta is this formula, pi over 180 times 72. And you could work that out. You could cancel 2 times 2 times 2 is 8, right? And that's 72. 8 divided by 72, that will give you a 9. And then you can divide here again by 9, you get 2, 0. So it's a 49 pi over 20. Alright, a 49 pi over 20. Let me write here, your A is half, let me write here 7/2, so it's easier to see 7/2 times, as I change the 72 degrees to radian, pi over 180 times 72. We have already cancelled this, and we've got a 9 here. We've cancelled this, we got a 20, and what we've got here is 7 times pi over 20. Pi can be 22 over 7. We take pi is 22 over 7, and we put the 20 here. We can change this, we can cancel this, we can cancel this, 11 over 10. What you've got, the area of sector is 77/10, which is 7.7 cm squared. Alright, but if you were to do this method, now let's take the other method, O method, which is 72/360. times pi r squared. Pi is 22 over 7. R is 7 over 2. 7 over 2. You could see we could cancel this by 72 and this will be 1/5, but if you're not very clear, we can divide by 6. That will be a 12. This will be a 60. Divide again by 12, you get a 5. And you could cancel 7 off. Cancel this here, you get 11. Alright, cancel this 7 off. 2 and 22 become 11. 11 times 7 is 77 over 10. And that will also give you a 7.7 cm squared. Ooh la la. So do not panic if you've forgotten the formula of half r squared theta. We could also use this fraction, very simple logical concept of how to find the area of this sector. Alright? Now the next thing they want to find is the area of this shaded region. How do you find the area of the shaded region? To find the area of this shaded region, we need to find the area of the triangle. Alright? And the area of triangle, you could use half AB sine C. Once you get the area of the triangle, half AB sine C. Okay? You take this sector minus the triangle will give us the shaded region. If you don't know how to use half AB sine C, you could cut this into here, right, into two parts. You need to find this length using trois quarts so. Then you can use base times height, divide by 2. You cut this in two equal parts, it's 36, 36. And then you can find out what is this length multiplied by 2. Then you find out what's this height using trois quarts so, 36 degrees, and find out what's this height. Base times height divided by 2. Alright, but that's really a long-winded way. I would suggest that you find the area of the triangle. Alright, area of triangle OPQ. Alright, or PQO, whatever. Half AB sine C. And what is that gonna be? Half times 3.5, 3.5 sine 72 degrees. Alright, so write that out. Half, use your formula. Half, what? 0.5, oh why? 0.5 times 3.5 times 3.5 times sine. Press sine 72 degrees and you would get your answer. You get 5.825. Alright? So the area of this triangle will be equal to 5.825. Okay? Now let me clear the space to show you more. Let me get this out of the way. Oh, good. I've got this lovely space here and we can write it out nicely. So the area of the shaded region will be the area of sector minus the area of triangle. So let's find out the area of triangle again. Area of triangle PQO will be equals to half AB sine C, and your formula half 3.5 times 3.5 sine 72 degrees. And we've got the area to be putting in the calculator 5.825. Alright, so therefore the area of the shaded region SR, will be the area of the sector minus the triangle. And the area of sector is 7.7 minus 5.825. Alright? And you will get this answer as 1.875 cm squared. You get that answer. I hope you're clear with that. Alright? Nothing really worrying. It's just a little bit of tedious calculation as we move on. So let's look at the sum again. It's a pentagon inside the circle. And they want to show this angle is 72 degrees. If you draw the pentagon to a center, you'll see that there are 5 vertices. And they all share the circle that is 360. 360 divided by 5, 72 degrees. Yes, you got that. Or you can do by many other methods that I shared with you. And then you want to find angle QSP. QSP, look at that. You look at that isosceles triangle, isosceles, congruent, 36, 36. So this will be 108, take away these two, 36, 36, you get a 36 degrees. Angle OTQ, OTQ, this is a beauty. Alright, draw the triangle out. You know this is made up of two of these, 72, 72, 144. 180 minus 144 divided by 2 because it's an isosceles triangle. When you see a circle with triangles inscribed, drawn inside it, do not get frightened. There's lots of going to be. You're going to see a lot of isosceles triangles there, and it will help you a lot in solving sums using base angle of isosceles triangle property. Alright? And then you want to find the area shaded region. You just find the area of this shaded region. Alright, you can use half r squared theta. Or you can do is a fraction of a circle, 72 degrees out of 360, which is 1/5 of pi r squared. So you work it out, you find the area sector, alright, and that will give us 1/5 of pi r squared, 7.7. And next what you got to do is minus the area of the triangle. Alright, it's half AB sine C. Alright, and you can work that out beautifully, and you take away area of sector minus area of circle, area of sector minus area of triangle. When you take that away, you get that shaded region. Beautiful. Alright, so move on. We've got the last sum to come. Keep smiling. Alright, and you'll find it getting a lot more easier.